Part II, Chapter 12, Part 3 of A Popular History of Astronomy during the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. A Popular History of Astronomy during the 19th Century by Agnes Mary Clerke. Chapter 12, Stars and Nebulae, Part 3. Every kind and degree of variability is exemplified in the heavens. At the bottom of the scales are stars like the sun, of which the lustre is, tried by our instrumental means, sensibly steady. At the other extreme are ranged the astounding apparitions of new or temporary stars. Within the last 36 years, 11 of these stellar guests, as the Chinese call them, have presented themselves, and we meet with a 12th no farther back than April 27, 1848. But of the new star in Ophiuchus, found by Mr. Hind on that night, little more could be learnt than of the brilliant objects of the same kind observed by Tycho and Kepler. The spectroscope had not then been invented. Let us hear what it had to tell of later arrivals. About 30 minutes before midnight of May 12, 1866, Mr. John Birmingham of Millbrook, near Tuam, in Ireland, saw with astonishment a bright star of the second magnitude, unfamiliarly situated in the constellation of the Northern Crown. 4 hours earlier, Schmidt of Athens had been surveying the same part of the heavens, and was able to testify that it was not visible there. That is to say, a few hours, or possibly a few minutes, sufficed to bring about a conflagration, the news of which may have occupied hundreds of years in travelling to us across space. The rays which were its messengers, admitted within the slit of Sir William Huggins's spectroscope, May 16, proved to be of a composition highly significant as to the nature of the catastrophe. The star, which had already declined below the third magnitude, showed what was described as a double spectrum. To the dusky flutings of Secchi's third type, 4 brilliant rays were added. The chief of these agreed in position with lines of a hydrogen, so that the immediate cause of the outburst was inferred to have been the eruption or ignition of vast masses of that subtle kind of matter, the universal importance of which throughout the cosmos is one of the most curious facts revealed by the spectroscope. T Coronae, as the new star was called, quickly lost its adventitious splendour. 9 days after its discovery, it was again invisible to the naked eye. It is now a pale yellow, slightly variable star near the 10th magnitude, and finds a place as such in Argelander's charts. It was thus obscurely known before it made its sudden leap into notoriety. The next temporary, discovered by Dr. Schmidt at Athens, November 24, 1876, could lay no claim to previous recognition, even in that modest rank. It was strictly a parvenu. There was no record of its existence until it made its appearance as a star of nearly the third magnitude in the constellation of the Swan. Its spectrum was examined December 2 by Cornu at Paris, and a few days later by Vogel and O. Lassi at Potsdam. It proved of a closely similar character to that of T Coronae. A range of bright lines, including those of hydrogen and probably of helium, stood out from a continuous background impressed with strong absorption. It may be presumed that in reality the gaseous substances which, by their sudden incandescence, had produced the apparent conflagration, lay comparatively near the surface of the star, while the screen of cooler materials intercepting large portions of its light was situated at a considerable elevation in its atmosphere. The object meanwhile steadily faded. By the end of the year it was of no more than seventh magnitude. After the second week of March, 1877, strengthening twilight combined with the decline of its radiance to arrest further observation. It was resumed September 2 at Denect, with a strange result. Practically the whole of its scanty light, it had then sunk below the 10th magnitude, was perceived to be gathered into a single bright line in the green, and that the most characteristic line of gaseous nebulae. The star had, in fact, so far as outward appearance was concerned, become transformed into a planetary nebula, many of which are so minute as to be distinguishable from small stars only by the quality of their radiations. It is now, having sunk to about the 14th magnitude, entirely beyond the reach of spectroscopic scrutiny. Perhaps none of the marvellous changes witnessed in the heavens has given a more significant hint as to their construction than the stellar blaze kindled in the heart of the great Andromeda Nebula, some undetermined number of years or centuries before its rays reached the earth in the month of August, 1885. The first published discovery was by Dr. Hartwig at Dorpat on August 31, but it was found to have been already seen on the 19th by Mr. Isaac W. Ward of Belfast, and on the 17th by M. Ludovic Gouly of Rouen. The negative observations on the 16th of Temple and Max Wolf limited very narrowly the epoch of the apparition. Nevertheless, it did not, like most temporaries, attain its maximum brightness all at once. When first detected, it was of the 9th. By September 1, it had risen to the 7th magnitude, from which it so rapidly fell off that in March it touched the limit of visibility, 16th magnitude, with the Washington 26-inch. Its light bleached very perceptibly as it faded. During the earlier stages of its decline, the contrast was striking between the sharply defined, ruddy disk of the star and the hazy greenish-white background upon which it was projected, and with which it was inevitably suggested to be in some sort of physical connection. Let us consider what evidence was really available on this point. To begin with, the position of the star was not exactly central. It lay 16 seconds of arc to the southwest of the true nebular nucleus. Its appearance did not then signify a sudden advance of the nebula towards condensation, nor was it attended by any visible change in it save the transient effect of partial effacement through superior brightness. Equally indecisive information was derived from the spectroscope. To Vogel, Hasselberg, and Young, the light of the nova seemed perfectly continuous, but Huggins caught traces of bright lines on September 2, confirmed on the 9th, and Copeland succeeded on September 30 in measuring 3 bright bands with an acute angled prism specially constructed for the purpose. A shimmer of F was suspected, and had also been perceived by Mr. O.T. Sherman of Yale College. Still, the effect was widely different from that of the characteristic blazing spectrum of a temporary star, and prompted the surmise that here, too, a variable might be under scrutiny. The star, however, was certainly so far new that its rays, until their sudden accession of strength, were too feeble to affect even our reinforced senses. Not one of the 1,283 small stars recorded in charts of the nebula could be identified with it, and a photograph taken by Dr. Common, August 16, 1884, on which a multitude of stars down to the 15th magnitude had imprinted themselves, showed the uniform soft gradation of nebulous light to be absolutely unbroken by a stellar indication in the spot reserved for the future occupation of the nova. So far, then, the view that its relation to the nebula was a merely optical one might be justified, but it became altogether untenable when it was found that what was taken to be a chance coincidence had repeated itself within living memory. On the 21st of May, 1860, Monsieur Auwers perceived at Königsberg a seventh magnitude star shining close to the centre of a nebula in Scorpio, numbered 80 in Messier's catalogue. 3 days earlier it certainly was not there, and 3 weeks later it had vanished. The effect to Mr. Pogson, who independently discovered the change May 28, was as if the nebula had been replaced by a star, so entirely were its dim rays overpowered by the concentrated blaze in their midst. Now, it is simply incredible that two outbursts of so uncommon a character should have accidentally occurred just on the line of sight between us and the central portions of two nebulae. We must then conclude that they showed on these objects because they took place in them. The most favoured explanation is that they were what might be called effects of overcrowding, that some of the numerous small bodies, presumably composing the nebulae, jostled together in their intricate circlings and obtained compensation and heat for their sacrifice in motion. But this is scarcely more than a plausible makeshift of perplexed thought. Mr. W. H. S. Monk, on the other hand, has suggested that new stars appear when dark bodies are rendered luminous by rushing through the gaseous fields of space, just as meteors kindle in our atmosphere. The idea, which has been revived and elaborated by Dr. Seeliger of Munich, is ingenious, but was not designed to apply to our present case. Neither of the objects distinguished by the striking variations just described is of gaseous constitution. That in Scorpio appears under high magnifying powers as a compressed cluster. That in Andromeda is perhaps, as Sir J. Herschel suggested, optically nebulous through the smallness of its constituent stars, if stars they deserve to be called. On the 8th of December, 1891, Dr. Max Wolf took a photograph of the region about Chi Aurigæ. No stranger so bright as the eighth magnitude was among the stars depicted upon it. On the 10th, nevertheless, a stellar object of the fifth magnitude, situated a couple of degrees to the northeast of Beta Tauri, and previously unrecorded, where 11th magnitude stars appeared, imprinted itself upon a Harvard negative. Subsequent photographs taken at the same place showed it to have gained about half a magnitude by the 20th, but the plates were not then examined, and the discovery was left to be modestly appropriated by an amateur, the Rev. Dr. Anderson of Edinburgh, by whom it was announced, February 1, 1892, through the medium of an anonymous postcard to Dr. Copeland, the Astronomer Royal for Scotland. By him and others, the engines of modern research were promptly set to work, and to good purpose. Nova Aurigæ was the first star of its kind studied by the universal chemical method. It is the first, accordingly, of which authentic records can be handed down to posterity. They are of a most remarkable character. The spectrum of the new object was photographed at Stonyhurst and South Kensington on February 3. A few days later at Harvard and Lick in America, at Potsdam and Héronie on the continent of Europe. But by far the most complete impression was secured February 22, with an exposure of an hour and 3/4 by Sir William and Lady Huggins, through whose kindness it is reproduced in Plate 5, Figure 1. The range of bright lines displayed in it is of astonishing vividness and extent. It includes all the hydrogen rays dark in the spectrum of Sirius, separately printed for comparison, besides many others still more refrangible, as yet unidentified. Very significant, too, is the marked character of the great prominence lines H and K. The visual spectrum of the nova was splendidly effective. A quartet of brilliant green rays, two of them due to helium, caught the eye, and they had companions too numerous to be easily counted. The hydrogen lines were broad and bright. C blazed, as Mr. Espin said, like a danger signal on a dark night. The sodium pair were identified at Tulse Hill, and the yellow helium ray was suspected to lurk close behind them. Figure 2 in the same plate shows the spectrum as it was seen and mapped by Lady Huggins, February 226, together with the spectra employed to test the nature of the emissions dispersed in it. One striking feature will be at once remarked. It is that of the pairing of bright with dark lines. Both in the visible and the photographic regions, this singular peculiarity was unmistakable, and since the two series plainly owned the same chemical origin, their separate visibility implied large displacement. Otherwise they would have been superposed, not juxtaposed. Measurements of the bright rays accordingly showed them to be considerably pushed down towards the red, while their dark companions were still more pushed up towards the blue end. Thus the spectrum of Nova Aurigæ, like that of Beta Lyrae, with which it had many points in common, appeared to be really double. It was supposed to combine the light of two distinct bodies, one of a gaseous nature moving rapidly away from the earth, the other giving a more sun-like spectrum, approaching it with even higher speed. The relative velocity determined at Potsdam for these oppositely flying masses amounted to 550 miles a second, and this prodigious rate of separation was fully maintained during 6 weeks. It did not then represent a mere periastral rush past. To the bodies exhibiting its effects and parting company forever under its stress, it must have belonged with slight diminution in perpetuity. The luminous outburst by which they became visible was explained by Sir William Huggins in a lecture delivered at the Royal Institution, May 13, 1892, on the tidal theory of Klinkerfues and Wilsing. Disturbances and deformations due to the mutual attraction of two bulky globes at a close approach would, he considered, give rise to enormous eruptions of the hotter matters from within, immensely greater but similar in kind to solar eruptions, and accompanied probably by large electrical disturbances. The multiple aspect and somewhat variable character of both bright and dark lines were plausibly referred to processes of reversal, such as are nearly always in progress among sun spots. But the long duration of the star's suddenly acquired lustre did not easily fit in with the adopted rationale. A direct collision, on the other hand, was out of the question, since there had obviously been little, if any, sacrifice of motion, and the substitution of a nebula for one of the stars compelled recourse to scarcely conceivable modes of action for an explanation of the perplexing peculiarities of the compound spectrum. An unexpected dénouement, however, threw all speculations off the track. The nova contained most of its brightness, fluctuations notwithstanding, until March 9, after which date it ran swiftly and uniformly down towards what was apprehended to be total extinction. No marked change of spectrum attended its decline. When last examined at Tulse Hill, March 24, all the more essential features of its prismatic light were still faintly recognizable. The object was steadily sinking on April 26, when a supposed final glimpse of it was caught with the Lick 36-inch. It was then of about the 16th magnitude, but on August 17 it had sprung up to the 10th, as Professors Holden, Schaeberle, and Campbell perceived with amazement on turning the same instrument upon its place. And to Professor Barnard it appeared 2 nights later not only revived, but transformed into the nucleus of a planetary nebula 3 minutes across. The reality of this seeming distension, however at once disputed, was eventually disproved. It unquestionably arose from the imperfect focusing power of the telescope for rays of unusual quality. The rekindled nova was detected in this country by Mr. H. Corder, on whose notification Mr. Espin, on August 21, examined its nearly monochromatic spectrum. The metamorphosis of Nova Cygni seemed repeated. The light of the new object, like that of its predecessor, was mainly concentrated in a vivid green band, identified with the chief nebular line by Copeland, von Goddard, and Campbell. The second nebular line was also represented. Indeed, the last named observer recognized nearly all the 18 lines measured by him in the nova as characteristic of planetary nebulae. Of particular interest is the emergence in the star spectrum photographed by von Goddard of an ultraviolet line originally discovered at Tulse Hill in the Orion Nebula, which is also very strong in the Lyra Annular Nebula. Obviously, then, the physical constitution of Nova Aurigæ became profoundly modified during the 4 months of its invisibility. The spectrum of February was, or appeared, compound. That of August was simple. It could be reasonably associated only with a single light source. Many of the former brilliant lines, too, had vanished and been replaced by others, at first inconspicuous or absent. As a result, the solar prominence type, to which the earlier spectrum had seemed to conform, was completely effaced in the later. The cause of these alterations remains mysterious, yet its effects continue. The chromatic behavior of the semi-extinct nova, when scrutinized with great refractors, shows its waning light to be distinctly nebular. Like nearly all its congeners, the star is situated in the full stream of the Milky Way, and we learn without surprise that micrometrical measures by Burnham and Barnard failed to elicit from it any sign of parallactic shifting. It is hence certain that the development of light, of which the news reached the earth in December 1891, must have been on a vast scale and of ancient date. Nova Aurigæ, at its maximum, assuredly exceeded the sun many times in brightness, and its conflagration can scarcely have occurred less, and may have occurred much more, than 100 years ago. By means of the photographic surveys of the skies, carried on in both hemispheres under Professor Pickering's superintendence, such amazing events have been proved to be of not infrequent occurrence. Within 6 years 5 new stars were detected from Draper Memorial, or chart plates by Mrs. Fleming, besides the retrospective discovery of a sixth, which had rapidly burnt itself out 8 years previously in Perseus. Nova Normae was the intermediate successor of Nova Aurigæ. Nova Carinae and Nova Centauri lit up in 1895, the latter in a pre-existent nebula. Nova Sagittarii and Nova Aquilae attained brief maxima in 1898 and 1899 respectively. Now, 3 out of these 5 stars reproduced with singular fidelity the spectrum of Nova Aurigæ. They displayed the same brilliant rays, shadowed invariably on their blue sides by dark ones. Palpably, then, the arrangement was systematic and significant. It could not result merely from the casually directed opposite velocities of bodies meeting in space. The hypothesis of stellar encounters accordingly fell to the ground, and has been provided with no entire satisfactory substitute. Most speculators now fully recognize that motion displacements cannot be made to account for the doubled spectra of novae, and seek recourse instead to some kind of physical agency for producing the observed effect. And since this is also visible in certain permanent though peculiar objects, notably in P Cygni, B Lyrae, and Eta Carinae, the acting cause must also evidently be permanent and inherent. The new star of the new century was a visual discovery. Dr. Anderson duplicated with added éclat his performance of 9 years back. In the early morning of February 22, 1901, he perceived that Algol had a neighbour of nearly its own brightness, which a photograph taken by Mr. Stanley Williams at Brighton proved to have risen from below the 12th magnitude within the preceding 28 hours. And it was still swiftly ascending. On the 23rd, it outshone Capella. For a brief space, it took rank as the premier star of the northern hemisphere. A decline set in promptly, but was pursued hesitatingly. The light fluctuated continually over a range of a couple of magnitudes, and with a close approach during some weeks to a 3-day periodicity. A year after the original outburst, the star was still conspicuous with an opera glass. The spectrum underwent amazing changes. At first continuous, save for fine dark lines of hydrogen and helium, it unfolded within 48 hours a composite range of brilliant and dusky bands disposed in the usual fashion of novae. These lasted until far on in March, when hydrogen certainly, and probably other substances as well, ceased to exert any appreciable absorptive action. Blue emissions of the Wolf-Rayet type then became occasionally prominent, in remarkable correspondence with the varying lustre of the star. Finally, a band at Lambda 3969, found by Wright at Lick to characterize nebular spectra, assumed abnormal importance, and in July the nebular transformation might be said to be complete. Striking alterations of colour attended these spectral vicissitudes. White to begin with, the star soon turned deep red, and its redness was visibly intensified at each of its recurring minima of light. Blanching, however, ensued upon the development of its nebulous proclivities, and its surviving rays are of a steely hue. All the more important investigations of Nova Persei were conducted by photographic means. Libraries of spectral plates were collected at the Yerkes and Lick observatories at South Kensington, Stonyhurst, and Potsdam, and await the more exhaustive interpretation of the future. Meanwhile, extraordinary revelations have been supplied by immediate photographic delineation. On August 22 and 23, 1901, Professor Max Wolf, by long exposures with the 16-inch Bruce twin objectives of the Koningsstuhl Observatory, Heidelberg, obtained indications of a large nebula finely ramified, extending southeast of the nova, and the entire formation came out in 4 hours with the Yerkes 2-foot reflector directed to it by Mr. Ritchie on September 20. It proved to be a great spiral encircling, and apparently emanating from the star; but if so, tumultuously, and under stress of catastrophic impulsions. A picture obtained by Mr. Perrine with the Crossley refractor in 7 hours 19 minutes on November 7 and 8 disclosed the progress of a startling change. Comparison with the Yerkes photograph showed that during the intervening 48 days 4 clearly identifiable condensations had become displaced, all to the same extent of about 90 seconds of arc and in fairly concordant directions, suggesting motion round the nova as well as away from it. The velocity implied, however, is so prodigious as virtually to exclude the supposition of a bodily transport of matter. It should be at the rate of no less than 20,000 miles a second, admitting the object to be at a distance from us corresponding to an annual parallax of 1/10 of a second, and actual measurements show it to be indefinitely more remote. The fact of rapid variations in the nebula was reaffirmed, though with less precision, from Yerkes photographs of November 9 and 13, Mr. Ritchie inferring a general expansion of its southern portions. Much further evidence must be at hand before a sane judgment can be formed as to the nature of the strange events taking place in that secluded corner of the galaxy, and it is highly probable that the illumination of the nebulous wreaths round the star will prove no less evanescent than the blazing of the star itself. We have been compelled somewhat to anticipate our narrative as regards inquiries into the nature of nebulae. The excursions of opinion on the point were abruptly restricted and defined by the application to them of the spectroscope. On August 29, 1864, Sir William Huggins sifted through his prisms the rays of a bright planetary nebula in Draco. To his infinite surprise, they proved to be mainly of one colour. In other words, they avowed their origin from a mass of glowing vapour. As to what kind of vapour it might be, by which Herschel's conjecture of a shining fluid diffused at large throughout the cosmos was thus unexpectedly verified, an answer only partially satisfactory could be afforded. The conspicuous bright line of the Draco nebula seemed to agree in position with one emitted by nitrogen, but has since proved to be distinct from it. Of its two fainter companions, one was unmistakably the F line of hydrogen, while the other, in position intermediate between the two, still remains unidentified. By 1868, Huggins had satisfactorily examined the spectra of about 70 nebulae, of which one-third displayed a gaseous character. All of these gave the green ray fundamental to the nebular spectrum, and emanating from an unknown form of matter named by Sir William Huggins nebulum. It is associated with 7 or 8 hydrogen lines, with 3 of yellow helium, and with a good many of undetermined origin. The absence of the crimson radiation of hydrogen, perceived with difficulty only in some highly condensed objects, is an anomaly very imperfectly explained as a physiological effect connected with the extreme faintness of nebular light. An approximate coincidence between the chief nebular line and a fluting of magnesium having been alleged by Lockyer in support of his meteoritic hypothesis of nebular constitution, it became of interest to ascertain its reality. The task was accomplished by Sir William and Lady Huggins in 1889 and 1890, and by Professor Keeler, with the advantages of the Mount Hamilton apparatus and atmosphere, in 1890–91. The upshot was to show a slight but sure discrepancy as to place, and a marked diversity as to character between the two qualities of light. The nebular ray, wave-length 5,007 millionths of a millimetre, is slightly more refrangible than the magnesium fluting edge, and it is sharp and fine, with no trace of the unilateral haze necessarily clinging even to the last remnant of a banded formation. End of chapter 12, part 3.
Part 2, Chapter 12 of A Popular History of Astronomy during the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Aaron Carlo in San Clemente, California. A Popular History of Astronomy during the 19th Century by Agnes Mary Clerke. Part 2, Chapter 12, Stars and Nebulae, Part 4. Planetary and annular nebulae are, without exception, gaseous, as well as those termed irregular, which frequent the region of the Milky Way. Their constitution usually betrays itself to the eye by their blue or greenish color, while those yielding a continuous spectrum are of a dull white. Among the more remarkable of these are the well-known nebula in Andromeda and the great spiral in Canes Venatici, and, as a general rule, the emissions of all such nebulae as present the appearance of star clusters grown misty through excessive distance are of the same kind. It would, however, be eminently rash to conclude thence that they are really aggregations of sun-like bodies. The improbability of such an inference has been greatly enhanced by the occurrence, at an interval of 1/4 of a century, of stellar outbursts in the midst of 2 of them. For it is practically certain that the temporary stars were equally remote with the hazy formations they illuminated. Hence, if the constituent particles of the latter be suns, the incomparable vaster orbs by which their feeble light was well nigh obliterated must, as was argued by Mr. Proctor, have been on a scale of magnitude such as the imagination recoils from contemplating. Nevertheless, Dr. Scheiner, not without much difficulty, obtained in January 1899 spectrographic prints of the Andromeda Nebula, indicative, he thought, of its being a cluster of solar stars. Sir William and Lady Huggins, on the other hand, saw, in 1897, bright intermixed with dark bands in the spectrum of the same object, and Mr. Maunder conjectures all white nebulae to be made up of sunlets in which the coronal element predominates, while chromospheric materials assert their presence in nebulae of the green variety. Among the ascertained analogies between the stellar and nebular systems is that of variability of light. On October 11th, 1852, Mr. Hind discovered a small nebula in Taurus. Chacornac observed it at Marseilles in 1854, but was confounded 4 years later to find it vanished. D'Arrest missed it October 3rd and redetected it December 29th, 1861. It was easily seen in 1865 through 1866, but invisible in the most powerful instruments from 1877 to 1880. Barnard, however, made out an almost evanescent trace of it October 15, 1890, with the great Lick telescope, and saw it easily in the spring of 1895, while 6 months later it evaded his most diligent search. Then again, on September 28, 1897, the Yerkes 40-inch disclosed it to him as a mere shimmer at the last limit of visibility, and it came out in 3 diffuse patches on plates to which, on December 6th and 27th, 1899, Keeler gave prolonged exposures with the Crossley reflector. Moreover, a fairly bright adjacent nebula, perceived by O. Struve in 1868 and observed shortly afterwards by D'Arrest, has totally vanished, and was most likely only a temporary apparition. These are the most authentic instances of nebular variability. Many others have been more or less plausibly alleged, But Professor Holden's persuasion, acquired from an exhaustive study of the records since 1758, that the various parts of the Orion Nebula fluctuate continually in relative luster, has not been ratified by photographic evidence. The case of the Trifid Nebula in Sagittarius, investigated by Holden in 1877, is less easily disposed of. What is certain is that a remarkable triple star centrally situated, according to the observations of both the Herschels, 1784 through 1833, in a dark space between the three great lobes of the nebula, is now, and has been since 1839, densely involved in one of them. And since the hypothesis of relative motion is on many grounds inadmissible, the change that has apparently taken place must be in the distribution of light. One no less conspicuous was adduced by Mr. H.C. Russell, director of the Sydney Observatory. A particular bright part of the great Argo Nebula, as drawn by Sir John Herschel, has, it would seem, almost totally disappeared. He noticed its absence in 1871 using a 7-inch telescope, failed equally later on to find it with an 11.5-inch, and his long exposure photographs show no vestige of it. The same structure is missing from, or scarcely traceable in, a splendid picture of the nebula taken by Sir David Gill in 12 hours distributed over 4 nights in March 1892. An immense gaseous expanse has, it would seem, sunk out of sight. Materially it is no doubt there, but the radiance has left it. Nebulae have no ascertained proper motions. No genuine change of place in the heavens has yet been recorded for any one of them. All equally hold aloof, so far as telescopic observation shows, from the busy journeyings of the stars. This seeming immobility is partly an effect of vast distance. Nebular parallax has, up to the present, proved evanescent, and nebular parallactic drift, in response to the sun's advance through space, remains likewise imperceptible. It may hence be presumed that no nebulae occur within the sphere occupied by the nearer stars. But the difficulty of accurately measuring such objects must also be taken into account. Displacements which would be conspicuous in stars might easily escape detection in ill-defined hazy masses. Thus, the measures executed by d'Arrest in 1857 have not yet proved effective for their designed purpose of contributing to the future detection of proper motions. Some determinations made by Mr. Burnham with the Lick refractor in 1891 will ultimately afford a more critical test. He found that nearly all planetary nebulae include a sharp stellar nucleus, the position of which with reference to neighboring stars could be fixed no less precisely than if it were devoid of nebulous surroundings. Hence, the objects located by him cannot henceforward shift, were it only to the extent of a small fraction of a second, without the fact coming to the knowledge of astronomers. The spectroscope, however, here as elsewhere, can supplement the telescope. And what it has to tell, it tells at once, without the necessity of waiting on time to ripen results. Sir William Huggins made, in 1874, the earliest experiments on the radial movements of nebulae, but with only a negative upshot. None of the 6 objects examined gave signs of spectral alteration, and it was estimated that they must have done so had they been in course of recession from or approach towards the Earth by as much as 25 miles a second. With far more powerful appliances, Professor Keeler renewed the attempt at Lick in 1890-91. His success was unequivocal. 10 planetary nebulae yielded perfectly satisfactory evidence of line-of-sight motion, the swiftest traveler being the well-known greenish globe in Draco, found to be hurrying towards the Earth at the rate of 40 miles a second. For the Orion Nebula, a recession of about 11 miles was determined, the whole of which may, however, very well belong to the solar system itself, which, by its translation towards the constellation Lyra, is certainly leaving the great nebula pretty rapidly behind. The anomaly of seeming nebular fixity has nevertheless been removed, and the problem of nebular motion has begun to be solved through the demonstrated possibility of its spectroscopic investigation. Keeler's were the first trustworthy determinations of radial motion obtained visually. That the similar work on the stars begun at Greenwich in 1874 and carried on for 13 years remained comparatively unfruitful was only what might have been expected, the instruments available there being altogether inadequate for the attainment of a high degree of accuracy. The various obstacles in the way of securing it were overcome by the substitution of the sensitive plate for the eye. Air tremors are thus rendered comparatively innocuous, and measurements of stellar lines displaced by motion with reference to fiducial lines from terrestrial sources photographed on the same plates can be depended upon within vastly reduced limits of error. Studies for the realization of the spectrographic method were begun by Dr. Vogel and his able assistant Dr. Scheiner at Potsdam in 1887. Their preliminary results, communicated to the Berlin Academy of Sciences March 15, 1888, already showed that the requirements for effective research in this important branch were at last about to be complied with. An improved instrument was erected in the autumn of the same year, and the 51 stars, bright enough for determination with a refractor of 11 inches aperture, were promptly taken in hand. A list of their motions in the line of sight, published in 1892, was of high value both in itself and for what it promised. One noteworthy inference from the data it collected was that the eye tends, under unfavorable circumstances, to exaggerate the line displacements it attempts to estimate. The velocities photographically arrived at were of much smaller amounts than those visually assigned. The average speed of the Potsdam stars came out only 10.4 miles a second, the quickest among them being Aldebaran, with a recession of 30 miles a second. More lately, however, Deslandres and Campbell have determined for Eta Hercules and Zeta Cephei, respectively, approaching rates of 44 and 54 miles a second. The installation in 1900 of a photographic refractor 31½ inches in aperture, coupled with a 20-inch guiding telescope, will enable Dr. Vogel to investigate spectrographically some hundreds of stars fainter than the second magnitude, and the materials thus accumulated should largely help to provide means for a definite and complete solution of the more than secular problem of the sun's advance through space. The solution should be complete because, including a genuine determination of the sun's velocity, apart from assumptions of any kind, M. Homann's attempt in 1885 to extract some provisional information on the subject from the radial movements of visually determined stars, gave a fair earnest of what might be done with materials of a better quality. He arrived at a goal for the sun's way shifted eastward to the constellation Cygnus, a result congruous with the marked tendency of recently determined apexes to collect in or near Lyra, and the most probable corresponding velocity seemed to be about 19 miles a second, or just that of the Earth in its orbit. A more elaborate investigation of the same kind, based by Professor Campbell in 1900 upon the motions of 280 stars, determined with extreme precision, suffered incompleteness through lack of available data from the southern hemisphere. The outcome, accordingly, was an apex most likely correctly placed as regards right ascension, but displaced southward by some 15 degrees. The speed of 12 miles a second assigned to the solar translation approximates doubtless very closely to the truth. A successful beginning was made in nebular spectrography by Sir William Huggins, March 7, 1882. 5 lines in all stamped themselves upon the plate during 45 minutes of exposure to the rays of the strange object in Orion. Of these, 4 were the known visible lines, and a 5th, high up in the ultraviolet at wavelength 3727, has evidently peculiar relationships, as yet imperfectly apprehended. It is strong in the spectra of many planetaries. It helped to characterize the nebular metamorphosis of Nova Aurigæ, yet failed to appear in Nova Persei. 2 additional hydrogen lines, making 6 in all, were photographed at Tulse Hill from the Orion Nebula in 1890, and Dr. Copeland's detection in 1886 of the yellow ray D3 gave the first hint of the presence of helium in this prodigious formation. Nor are there wanting spectroscopic indications of its physical connection with the stars visually involved in it. Sir William and Lady Huggins found a plate exposed February 5, 1888, impressed with 4 groups of fine bright lines, originating in the continuous light of 2 of the trapezium stars, but extending some way into the surrounding nebula. And Dr. Scheiner argued a wider relationship from the common possession by the nebula and the chief stars in the constellation Orion, of a blue line, bright in the one case, dark in the others, since identified as a member of one of the helium series. The structural unity of the stellar and nebular orders in this extensive region of the sky has also, by direct photographic means, been unmistakably affirmed. The first promising autographic picture of the Orion Nebula was obtained by Draper September 30, 1880. The marked approach towards a still more perfectly satisfactory result shown by his plates of March 1881 and 1882 was unhappily cut short by his death. Meanwhile, Monsieur Janssen was at work in the same field from 1881 with his accustomed success. But Dr. A. Ainslie Common left all competitors far behind with a splendid picture taken January 30, 1883, by means of an exposure of 37 minutes in the focus of his 3-foot silver-on-glass mirror. Photography may thereby be said to have definitely assumed the office of historiographer to the nebulae, since this one impression embodies a mass of facts hardly to be compassed by months of labor with the pencil, and affords a record of shape and relative brightness in the various parts of the stupendous object it delineates, which must prove invaluable to the students of its future condition. Its beauty and merit were officially recognized by the award of the Astronomical Society's Gold Medal in 1884. A second picture of equal merit, obtained by the same means February 28, 1883, with an exposure of 1 hour, is reproduced in the frontispiece. The vignette includes 2 specimens of planetary photography. The Jupiter, with the great red spot conspicuous in the southern hemisphere, is by Dr. Common. It dates from September 3, 1879, and was accordingly one of the earliest results with his 36-inch, the direct image in which imprinted itself in a fraction of a second, and was subsequently enlarged on paper about 12 times. The exquisite little picture of Saturn was taken at Paris by Messieurs Paul and Prosper Henry, December 21, 1885, with their 13-inch photographic refractor. The telescopic image was in this case magnified 11 times previous to being photographed, an exposure of about 5 seconds being allowed, and the total enlargement, as it now appears, is 19 times. A trace of the dusky ring perceptible on the original negative is lost in the print. A photograph of the Orion Nebula, taken by Dr. Roberts in 67 minutes, November 30, 1886, made a striking disclosure of the extent of that prodigious object. More than 6 times the nebulous area depicted on Dr. Common's plates is covered by it, and it plainly shows an adjacent nebula, separately catalogued by Messier, to belong to the same vast formation. This disposition to annex and appropriate has come out more strongly with every increase of photographic power. Plates exposed at Harvard College in March, 1888, with an 8-inch portrait lens, the same used in the preparation of the Draper catalogue, showed the old established fish-mouth nebula not only to involve the stars of the sword handle, but to be in tolerably evident connection with the most easterly of the three belt stars, from which a remarkable nebulous appendage was found to proceed. A still more curious discovery was made by W. H. Pickering in 1889. Photographs taken in 3 hours from the summit of Wilson's Peak in California revealed the existence of an enormous, though faint, spiral structure, enclosing in its span of nearly 17 degrees the entire stellar and nebulous group of the Belt and Sword, from which it most likely, although not quite traceably, issues as if from a nucleus. A startling glimpse is thus afforded of the cosmical importance of that strange hiatus in the heavens which excited the wonder of Huygens in 1656. The inconceivable attenuation of the gaseous stuff composing it was virtually demonstrated by Mr. Ranyard. In March 1885, Sir Howard Grubb mounted for Dr. Isaac Roberts at Maghull, near Liverpool (his observatory has since been transferred to Crowborough in Sussex), a silver-on-glass reflector of 20 inches aperture, constructed expressly for use in celestial photography. A series of nebula pictures obtained with this fine instrument have proved highly instructive both as to the structure and extent of these wonderful objects. Above all, one of the great Andromeda Nebula, to which an exposure of 3 hours was given on October 1st, 1888. In it, a convoluted structure replaced and rendered intelligible the anomalously rifted mass seen by Bond in 1847. The effects of annular condensation appeared to have stamped themselves upon the plate, and 2 attendant nebulae presented the aspect of satellites already separated from the parent body, and presumably revolving round it. The Ring Nebula in Lyra was photographed at Paris in 1886, and shortly afterwards by von Gothard with a 10-inch reflector, and he similarly depicted in 1888 the 2 chief spiral and other nebulae. Photographs of the Lyra Nebula taken at Algiers in 1890 and at the Vatican Observatory in 1892 were remarkable for the strong development of a central star, difficult of telescopic discernment, but evidently of primary importance to the annular structure around. The uses of photography in celestial investigations become every year more manifold and more apparent. The earliest chemical star pictures were those of Castor and Vega, obtained with the Cambridge refractor in 1850 by Whipple of Boston under the direction of W. C. Bond. Double star photography was inaugurated under the auspices of G. P. Bond, April 27, 1857, with an impression obtained in 8 seconds of Mizar, the middle star in the handle of the plough. A series of measures from 62 similar images gave the distance and position angle of its companion with about the same accuracy attainable by ordinary micrometrical operations. And the method and upshot of these novel experiments were described in 3 papers remarkably forecasting the purposes to be served by stellar photography. The matter next fell into the able hands of Rutherford, who completed in 1864 a fine object glass of 11½ inches, corrected for the ultraviolet rays, consequently useless for visual purposes. The sacrifice was recompensed by conspicuous success. A set of measurements from his photographs of nearly 50 stars in the Pleiades, and their comparison with Bessel's places, enabled Dr. Gould to announce, in 1866, that during the intervening third of a century no changes of importance had occurred in their relative positions. And Mr. Harold Jacobi similarly ascertained the fixity of 75 of Rutherford's Atlantids, between the epoch 1873 and that of Dr. Elkin's heliometric triangulation of the cluster in 1886, extending the interval to 27 years by subsequent comparisons with plates taken at Lick, September 27, 1900. Positive, however, as well as negative results have ensued from the application of modern methods to that antique group. On October 19, 1859, Wilhelm Tempel, a Saxon peasant by origin, later a skilled engraver, discovered with a small telescope bought out of his scanty savings an elliptical nebulosity stretching far to the southward from the star Merope. It attracted the attention of many observers, but was so often missed owing to its extreme susceptibility to adverse atmospheric influences as to rouse unfounded suspicions of its variability. The detection of this evasive object gave a hint, barely intelligible at the time, of further revelations of the same kind by more cogent means. A splendid photograph of 1,421 stars in the Pleiades, taken by Messrs. Henry with 3 hours exposure, November 16, 1885, showed one of the brightest of them to have a small spiral nebula, somewhat resembling a strongly curved comet's tail, attached to it. The reappearance of this strange appurtenance on 3 subsequent plates left no doubt of its real existence, visually attested at Pulkowa, February 5, 1886, by one of the first observations made with the 30-inch equatorial. Much smaller apertures, however, sufficed to disclose the Maya Nebula, once it was known to be there. Not only did it appear greatly extended in the Vienna 27-inch, but Messrs. Perrotin and Tholan saw it with the Nice 15-inch, and M. Kammermann of Geneva employing special precautions with a refractor of only 10 inches aperture. The advantage derived by him for bringing it into view from the insertion into the eyepiece of a uranium film gives, with its photographic intensity, valid proof that a large proportion of the light of this remarkable object is of the ultraviolet kind. The beginning thus made was quickly followed up. A picture of the Pleiades, procured at Magol in 89 minutes, October 23, 1886, revealed nebulous surroundings to no less than 4 leading stars of the group, namely Alcyone, Electra, Merope, and Maya. And a second impression, taken in 3 hours on the following night, showed further that the nebulosity extends in streamers and fleecy masses till it seems almost to fill the spaces between the stars and to extend far beyond them. The coherence of the entire mixed structure was, moreover, placed beyond doubt by the visibly close relationship of the stars to the nebulous formations surrounding them in Dr. Roberts' striking pictures. Thus Goldschmidt's notion that all the clustered Pleiades constitute, as it were, a second Orion trapezium in the midst of a huge formation of which Tempel's nebula is but a fragment, has been to some extent verified. Yet it seemed fantastic enough in 1863. Then, in 1888, the Messrs. Henry gave exposures of 4 hours each to several plates which exhibited on development some new features of the entangled nebulae. The most curious of these was the linking together of stars by nebulous chains. In one case, 7 aligned stars appeared strung on a silvery filament like beads on a rosary. The row of stars, so often noticed in the sky, may then be concluded to have more than an imaginary existence. Of the 2,326 stars recorded in these pictures, a couple of hundred among the brightest can, at the outside, be reckoned as genuine Pleiades. The great majority were relegated, by Pickering's and Stratonoff's counts of the stellar populace, in and near the cluster to the position of outsiders from it. They are undistinguished denizens of the abysmal background upon which it is projected. Investigations of its condition were carried a stage further by Barnard. On November 14, 1890, he discovered visually, with the Lick refractor, a close nebulous satellite to Merope, photographs of which were obtained by Keeler in 1898. It appears in them of a rudely pentagonal shape, a prominent angle being directed towards the adjacent star. Finally, an exposure of 10 hours made by Barnard with the Willard lens indicated the singular fact that the entire group is embedded in a nebulous matrix, streaky outliers of which blur a wide surface of the celestial vault. The artist's conviction of the reality of what his picture showed was confirmed by negatives obtained by Bailey at Arequipa in 1897 and by H. C. Wilson at Northfield, Minnesota, in 1898. With the Ealing 3-foot reflector, sold by Dr. Common to Mr. Crossley, and by him presented to the Lick Observatory, Professor Keeler took in 1899 a series of beautiful and instructive nebula photographs. One of the Trifid may be singled out as of particular excellence. An astonishing multitude of new nebula were revealed by trial exposures with this instrument. A conservative estimate gave 120,000 as the number coming within its scope. Moreover, the majority of those actually recorded were of an unmistakable spiral character, and they included most of Sir John Herschel's double nebula, previously supposed to exemplify the primitive history of binary stellar systems. Dr. Max Wolf's explorations with a 6-inch Vogtländer lens in 1901 emphatically reaffirmed the inexhaustible wealth of the nebular heavens. In one restricted region, midway between Precipice and the Milky Way, he located 135 nebula, where only 3 had until then been catalogued, and he counted 108 such objects clustering round the star 31 Coma Berenices, and so closely that all might be occulted together by the moon. The general photographic catalogue of nebula which Dr. Wolf had begun to prepare will thus be a most voluminous work. The history of celestial photography at the Cape of Good Hope began with the appearance of the great comet of 1882. No special apparatus was at hand, so Sir David Gill called in the services of a local artist, Mr. Alice of Mowbray, with whose camera, strapped to the observatory equatorial, pictures of conspicuous merit were obtained. But their particular distinction lay in the multitude of stars begemming the background. See Plate 3. The sight of them at once opened to the royal astronomer a new prospect. He had already formed the project of extending Agelende's Durchmusterung from the point where it was left by Schönfeld to the southern pole, and his ideas regarding the means of carrying it into execution crystallized at the needle touch of the cometary experiments. He resolved to employ photography for the purpose. The exposure of plates was accordingly begun under the care of Mr. Ray Woods in 1885, and in less than 6 years the sky, from 19 degrees of south latitude to the pole, had been covered in duplicate. Their measurement and the preparation of a catalogue of the stars imprinted upon them were generously undertaken by Professor Kapteyn, and his laborious task has at length been successfully completed. The publication in 1900 of the third and concluding volume of the Cape Photographic Durchmusterung placed at the disposal of astronomers a photographic census of the heavens fuller and surer than the corresponding visual enumeration executed at Bonn. It includes 454,875 stars, nearly to the 10th magnitude, and their positions are reliable to about 1 second of arc. The production of this important work was thus a result of the Cape Comet pictures, yet not the most momentous one. They turned the scale in favor of recourse to the camera when the Messrs. Henry encountered, in their continuation of Chacornac's half-finished enterprise of ecliptical charting, sections of the Milky Way defying the enumerating efforts of eye and hand. The perfect success of some preliminary experiments made with an instrument constructed by them expressly for the purpose was announced to the Academy of Sciences at Paris, May 2, 1885. By its means, stars estimated as of the 16th magnitude clearly recorded their presence and their places, and the enormous increase of knowledge involved may be judged of from the fact that, in a space of the Milky Way in Cygnus 2 degrees 15 minutes by 3 degrees, where 170 stars had been mapped by the old laborious method, about 5,000 stamped their images on a single Henry plate. These results suggested the grand undertaking of a general photographic survey of the heavens, and Gill's proposal, June 4, 1886, of an international congress for the purpose of setting it on foot was received with acclamation and promptly acted upon. 56 delegates of 17 different nationalities met in Paris, April 16, 1887, under the presidentship of Admiral Mouche, to discuss measures and organize action. They resolved upon the construction of a photographic chart of the whole heavens, comprising stars of a 14th magnitude to the surmised number of 20 millions, to be supplemented by a catalogue framed from plates of comparatively short exposure, giving start to the 11th magnitude. These will probably amount to about 1 million and a quarter. For procuring both sets of plates, instruments were constructed precisely similar to that of Messrs. Henry, which is a photographic refractor, 13 inches in aperture, and 11 feet focus, attached to a guiding telescope of 11 inches aperture, corrected, of course, for the visual rays. Each place covers an area of 4 square degrees, and since the series must be duplicated to prevent mistakes, about 22,000 plates will be needed for the chart alone. The task of preparing them was apportioned among 18 observatories scattered over the globe, from Mexico to Melbourne. But 3 in South America, having become disabled or inert, were replaced in 1900 by those at Cordoba, Montevideo, and Perth, Western Australia. Meanwhile, the publication of results has begun and is likely to continue for at least a quarter of a century. The first volume of measures from the Potsdam catalogue plates was issued in 1899, and its successors, if on the same scale, must number nearly 400. Moreover, 96 heliogravure enlargements from the Paris chart plates, distributed in the same year, supplied a basis for the calculation that the entire atlas of the sky, composed of similar sheets, will form a pile 30 feet high and 2 tons in weight. It will, however, possess an incalculable scientific value, for millions of stars can be determined by its means from their imprinted images with an accuracy comparable to that attainable by direct meridian observations. One of the most ardent promoters of the scheme, it may be expected to realize, was Admiral Mouche, the successor of Leverrier in the direction of the Paris Observatory. But it was not granted to him to see the fruition of his efforts. He died suddenly June 25, 1892. Although not an astronomer by profession, he had been singularly successful in pushing forward the cause of the science he loved, while his genial and open nature won for him wide personal regard. He was replaced by M. Tisserand, whose mathematical eminence fitted him to continue the traditions of Delaunay and Leverrier. But his career, too, was unhappily cut short by an unforeseen death on October 20th, 1896. And the more eminent among the many qualifications of his successor, M. Maurice Louis, are of the practical kind. The sublime problem of the construction of the heavens has not been neglected amid the multiplicity of tasks imposed upon the cultivators of astronomy by its rapid development. But data of a far higher order of precision and indefinitely greater in amount than those at the disposal of Herschel or Struve must be accumulated before any definite conclusions on the subject are possible. The first organized effort towards realizing this desideratum was made by the German Astronomical Society in 1865, 2 years after its foundation at Heidelberg. The original program consisted in the exact determination of the places of all Argelander's stars to the 9th magnitude, exclusive of the polar zone, from the reobservation of which, say in the year 1950, astronomers of 2 generations hence may gather a vast store of knowledge, directly of the apparent motions, indirectly of the mutual relations binding together the suns and systems of space. 13 observatories in Europe and America joined in the work, now virtually terminated. Its scope was, after its inception, widened to include southern zones as far as the Tropic of Capricorn, this having been rendered feasible by Schoenfeld's extension, 1875 through 1885, of Argelander's survey. 30,000 additional stars thus taken in were allotted in zones to 5 observatories. Another important undertaking of the same class is the reobservation of the 47,300 stars in Lalande's Histoire Céleste. Begun under Arago in 1855, its upshot has been the publication of the Great Paris Catalogue, issued in 8 volumes between 1887 and 1902. From a careful study of their secular changes in position, M. Bossuet has already derived the proper motions of a couple of thousand out of nearly 50,000 stars enumerated in it. End of Part 2, Chapter 12, Stars and Nebulae, Part 4. Recording by Aaron Carlo in San Clemente, California.